All right, Math 12A, section 7.5. The last thing we did was I did a video going over some answers for section 7.4. Hopefully that helped. Again, if you are lost, please be communicating with me. Be asking questions. If I can't answer it through a video, if I do a video and you still don't get it, please talk to me about that. We can always do a video chat either through Hangouts or Zoom or whatever, and we can try and fix whatever is broken. Maybe I can say it differently. Maybe one-on-one I can explain it better. We'll try and kind of figure this out. All right. So section 7.5 is on tangents to a circle. So let's talk about what that even is. If you have a circle and you have a line on the edge of a circle that only touches the edge of the circle in one spot. So let's say it just touches the edge of the circle here. This is a tangent line. I gotta get a new marker. This one is fading. This is a tangent line because it only touches the edge of the circle in that one spot. The spot where it touches the circle is called the point of tangency. Now you can have more than one tangent line on a circle. For instance, I could have another point of tangency here, and that would do this, okay? And you'll notice what happens is these two lines actually eventually cross. That's not a perfect picture, of course, but it's the best I can do. I could even draw a tangent line here where it goes up here and down here, and again eventually these tangent lines will touch or cross, okay? I'm doing it this way on purpose because this is going to lead me into an example. Now there are some theorems about these things, so we have to talk about that. A tangent to a circle is always perpendicular to the radius at the point of tangency. So what I mean by that is, if here's the center of the circle and I draw a radius from here to the point where that tangent line touches the circle, these two, the tangent line and the radius, are at right angles to one another. They always are, okay? So a tangent line and a radius, where they connect, those are always at right angles to one another. They are perpendicular to one another. That is a theorem. That is on page 427. That is on page 427, that theorem. So page 427 says a radius and a tangent line at the point of tangency, the point where that tangent line touches the circle, they're always at right angles to one another. The tangent segments to a circle from any external point are congruent. Okay, that sounds complicated, and it's not. Notice when I drew this tangent line, okay, and I drew this tangent line, there is a point at which they either meet or cross, depending on how long you make your line. From the point of tangency to the point where they touch, so from this point of tangency to where this touches and the point, these two lines have to be the same length. So again, here's a point of tangency, and here's a point of tangency, and they meet out here. So this and this would have to be equal. Same thing here. This and this would have to be equal. All right. So if from the point of tangency, from 2 points of tangency to where they meet, those 2 lines have to be the same length. Have to be. That is listed on page 429. The way they word it is they say the tangent segments to a circle from any external point are congruent, are the same. I'm putting it in English and saying from any external point where they meet to their points of tangency, to the points where they touch the circle, those 2 lines have to be the same length. That's in English, all right? Believe it or not, I know. Okay. So, in example number 5, I've skipped the other examples. In example number 5, on page 429, this is actually the picture they give us, but they didn't put any of the little things in here because we're supposed to know that, right? So they didn't tell us any of this. They label it R, S, T, and A, B, and C. And they don't have a thing in there. Now, they tell us that TS is equal to TR. So they're saying this line, TS and TR, those are the same length, okay? This line and this line are the same length. They're telling us that. So let me write that up here. TS and TR are the same length. They're telling us that. The perimeter of this triangle, I'll write it perimeter, just so you don't think it's like a P that's supposed to be on there, is 44 centimeters. So all the way, if this length plus this length is 44 centimeters, okay? From S to C, so from here to here, this right here, okay, is 6 centimeters. They want us to find the length of TR. They want us to find the length of this line right here. I will put that in green. They want us to know, figure out what is TR. And what we're going to do is we're going to use all the stuff we just learned about tangency to figure this out. So if from here to here is 6, and that's a tangent point to an external point, that's a tangent point to an external point, that also has to be 6. They have to be equal, okay? So we know that. Also, we know that whatever this is, because again, tangent point to here, tangent point to here. So we know that that has to be true. I'm just trying to go through their logic here. SC equals RA. Yep. And if we know that this whole line is equal to this whole line, and we know that this is equal to this, we know that this part's equal to this part, then this also has to equal this. It's just logical, right? If this length and this length are the same from T to S, and from, wait, did they say T? Yeah, they said TS and TR are equal, sorry. And TC has to equal TA, so TC has to equal, what? Yeah, TC, do I have my things, oh, I have my things labeled wrong, no wonder. Okay, let me label my stuff right. I just had those two mixed up, no wonder. T and S, that makes more sense. Now it makes sense. So we know that TS equals TR, We want to know what TR is. So it's not that we're trying to figure out. It's not that, it's here. We're trying to figure out TR. Okay, so they have a lot of letters on here, so just let me kind of go through their logic. Okay, so SC has to equal RA. Yes, we've been through that. Okay. SC equals SB. Yes. And, okay, so these two lines are the same and these two lines are the same, which means this one also has to be equal. All of these have to be the same. This one, this one, this one, and this one have to be the same. So, if that's true, and the perimeter is 44, all the way around is 44. If we call this length from here to here, if we call this X, and this is the same as this, then it's also X. And if this is the same as this, then it's also X. And if this is the same as this, then it's also X. So if I were doing this, I would say that my perimeter is 6 plus 6 plus X plus X plus X plus X is 44. 1, 2, 3, 4 X's. So 6 plus 6 is 12, and that's 4 X's is equal to 44. So if we move this over here, 4X is 44, take away 12, which would be 32, and so X would be 8. And so if X is 8, if I'm right, which I think they're saying I'm not, but anyway, let's find out. If X is 8, then this is 8, and the length of the line would be 14, but they're saying 16, so let me see what I did wrong. $44. I did that right. Maybe I did some math wrong here. So 1, 2, 3, 4 X's. Yep, and 12. 44, take away 12. Well, that'd be 34, 32. That'd be 8. I get 14. Hold on, let me look and see what. Okay, so you're probably yelling at your screens now, telling me. So SC is equal to RA. I was with them, which is equal to SB. I was with them, which was equal to RB, and I was with them, and they say that is equal to 6. Oh, because way back at the beginning, I had this labeled wrong because I had my S's wrong. So they said SC is 6. So if that's 6, then that is 6, then that is 6, then that is 6. That makes more sense. All right, so it all had to do with my labeling. So let's do this again so that you are with me, I hope. Okay, so now that it's labeled right, they tell us that TS from here to here is equal to TR from here to here. They tell us that the whole perimeter is 44, all right? And they tell us that SC from here to here, from here to here, that is 6. Now, this is a point of tangency out to an external point. This is also a point of tangency to the same external point. So those two have to be equal. They also tell us that TS is equal to TR, and they also tell us that we also know that this is a point of tangency out to an external point, this is a point of tangency out to the same external point. So this and this are the same. So that point, that line and that line are the same. If that is 6, and this is x, and this is also x, because I don't know the length of it, then this has to be 6, because the two lines are the same length. So it has to be 6 plus x and 6 plus x. But if that's 6, and that's a point of tangency, and that's an external point, and that's a point of tangency, and that's an external point, that also has to be 6. Huh. So I have from here to here, that's x. I have from here to here, that's also x. I have this, which is 6, this, which is 6, this, which is 6, and this, which is 6. So that is a total of 24. That has to equal 44. So I have 2x. If I move this over here, 2x is equal to 20. So x is equal to 10. And so the length of this line from T to R is 10 plus 6, which is 16. Wow, that's not fun. I would look that over a couple of times in your book on page 429. I would look that over a couple of times. It's really hard to explain. So I would look through it a few times. Again, page 429. There's one more theorem that they haven't talked about in terms of tangents. Usually it's the theorem I screw up, but this time I think it was that one. All right, so here's the theorem. Then I'm going to explain it, okay? It says the angle between a tangent and a chord is equal to the inscribed angle on the opposite side of the chord. So here's what they're talking about. We're going to be putting triangles inside circles, inside triangles. It's going to be great. Okay, so let me see if I can explain this. And these are the hardest ones you're going to get to. These are the most complicated looking things. If you are able to kind of isolate parts of your picture a little bit, just look at a piece of it at a time, because when you look at the whole picture, it looks confusing. So if I have a circle, okay, I'm going to do this in several different colors, I think. So I have a circle. A chord is just a line that goes from one side of the circle to the other side of the circle. So here's a chord. Okay, here's another chord. And here's another chord. Those three chords together make a triangle inside the circle. This is an inscribed angle because it's at the edge of a circle. That's all inscribed angle means. It means an angle at the edge of a circle. There's another inscribed angle and there's another inscribed angle. So here's a chord, here's another chord, here's an inscribed angle, here's an inscribed angle, here's an inscribed angle. Now at the inscribed angles, where those angles meet on the edge of a circle, I can make a tangent line. I'm going to do it in red. I can make a tangent line, so I can draw a tangent. Now, again, you're looking at my drawings, I'm sorry. Here's a tangent line. Here's a tangent line. Here's a tangent line, okay? So we have a similar picture to what we had before, but we've added the element of another triangle inside that circle. Okay. Now the theorem that I read to you a minute ago. Let's talk about it again, okay? It says the angle between a tangent and a chord. So the angle between a tangent line and a chord. So let's say that. An angle between a tangent line and a chord. That angle is equal equal to the inscribed angle on the opposite side of the chord. So here's what I do. This angle is touching this chord right here. It's touching this chord that's going straight up and down. The inscribed angle that is across from that angle, this angle and this angle would be the same. So let me say it again. The angle between a tangent line and a chord is equal or the same as the inscribed angle that's across from that chord. Got it? I said it as slowly as I could. If you need to, back it up and listen to me say that a couple more times. All right, so I'm going to try and label this correctly this time. This, by the way, is example number 7 on page 430. On page 430, that is where it is, okay? So we have, I'm going to label this right this time. We have A, B, C, D, oh, see, I was almost going to do it, E, and F, all right? Now, they tell us that angle DFE, so this angle right here, they tell us is 70 degrees. And CEF is 60, CEF, okay? So this angle from this chord to that point of tangency, that is 60. Find the measures of angle ABC. So I'm going to label that X. We want to find that. And ADF. We want to find this one, which is Y. All right. So that's what we know and what we want to figure out. Now, again, normally if I was sitting in a class with you guys, what I would now be doing is turning it over to you and getting you to throw ideas at me as to where could I go from here. But you're not here. So that leaves me and my brain. Thanks so much, guys. So here's what I'm going to do. First off, if this is 70, I know that is 70. Again, because of that thing, right? From the tangent line to the chord is the same as the opposite angle to that chord. So if that's 70, the opposite chord, that angle. By the way, it also means that this is 70 because again, there's the chord, there's the opposite angle. All right. I could figure out this because that looks like half a circle to me. So if that's 70 and that's 60, that's 130. And we know the whole thing's got to be 180 because it's half a circle. So 70 plus 60 is 130. So that means this would have to be 50 degrees. I got that. Again, I don't know where I'm going with this, guys. I'm just figuring out what I can. If that's 70 and that's 50, and this is a triangle, all three angles have to add up to give me 180. 70 and 50 is 120, which means this has to be 60, which makes sense because over here they told me from this tangent line to this chord is 60. So this is the chord that's touching. So directly opposite that is that angle. That one and that one should be equal. I now also can tell them that Y is 50 degrees. because if that's 50, there's the chord, there's the angle between the chord and the tangent line. And by the way, this one would also be 50, and that means this one would also be 60. I don't know if I need all that or not, but that is one of the things they wanted me to find. I need to figure this angle out here, and it doesn't appear to have anything to do with anything here. So, what can I do? What can I do? Oh, I see a very simple thing, but I'm going to do it with green. I actually see a really simple thing now that I've figured that out. Again, it's all about, can you take a picture and look at it in a bunch of different ways? Can you pull it apart? Because you can look at it as it's a triangle inside a circle inside another triangle, but look here, this line and this line and this line, doesn't that make a triangle? Isn't that a triangle right there? And if that's a triangle, all the angles have to add up to give me 180. And if I knew that that was 70, which I already figured out, and I knew that that was 70, which I already figured out, and I know that all angles have to add up to give me 180, 70 and 70 is 140, which means this has to be 40 degrees. Now, is that the only way to figure that out? Nope. It's not even the way they do it in the textbook, but it's what I saw. So, again, it's, can you look at things with different perspectives? You might look at it one way to figure out one angle, but then kind of change your view. I've even gone so far with some of these as to take my textbook and even rotate it, move it around, just so I get a different perspective on the picture, because sometimes that will help me see something that when I was looking at it right side up, I didn't see. You have to figure out coping mechanisms for this, because there is not a method for this. This is not algebra where it's step 1, you isolate your x. Step 2, it's this. It's not like that. You have to be able to look at the picture and be able to pull it apart. Like I said, this chapter for some people, they love it because they can see it really well. Their brain just works that way. For other people, this is a really difficult section because their brain has a harder time doing that. For me in high school, this would have been really, really hard for me. It's easier now because I'm older and have a lot of practice at it. But when I first started, this would have been like the worst thing in the world for me. So I will post some questions for you to do. They will be due on Monday. Have a good weekend, and we'll talk to you again on Monday. Please let me know how this goes. Send me your finished work with any questions that you have. It's easier for me if some of you are already doing this. If you have questions, you put it down in a private message when you upload it, or you put it in Google Hangouts, one of the two, somewhere where I'm going to see it. When I'm scanning through your work, I don't always catch, if you put a question on it, I don't always catch it. So if I ever miss answering a question of yours, please ask it a second time. It doesn't mean I'm ignoring you. It means I might have missed it. There's a lot of information coming in at me. There's a lot of questions being asked. I don't mean to miss anyone, but if I do, please speak up and say I still don't get whatever. All right? Have a good weekend. See you later.